Hello, class. This is section 3.6. This will be the last section we do before our first exam. And this is more of an application section. And history has shown this is a pretty challenging section for the students. So what I've decided to do, and the title of this is Build and Analyze Functions. So basically what we're going to do is a subset of this section. We're going to do a distance formula, and then we're going to analyze some simple geometric figures, mainly boxes. And so I'm going to walk through 3 different examples. And the first one is the example of measuring distance from the origin to any point on an equation or in this case, a function. So it's finding distance from a point, say, and we're going to deal with the origin, which is 0, 0. So let's just stick with the origin to any point on the line. More specifically, any point to a graph. There we go, a little bit. So what we're going to do in this example is we're going to take the function f of x equals x squared minus 1. And if we graph that equation, it would look like this. So it would be here minus 1, and it would go through here. It would look like that. The parabola pointed up. And so what we're going to do is I'm going to show you how to derive an equation to measure distance. And for those of you heading on to trig, we talk about measuring distance all the time, with trig functions, etc. So this is a really nice application to get you ready for that. So we're going to just deal with a distance from the origin. So you see where that red? And any point on, or any spot on this graph. So say like I picked this. So we would be able, with the equation I'm going to show you how to derive, we're going to be able to plug in values, specifically the x value, and you're going to be able to calculate the distance of that line from the origin to that point on the graph. And let me show you a little prettier picture. So if you looked in the book, you would see that this figure here gives you the distance from the origin at any point on that graph. So how do we do this? Get the whiteboard back up. And so we call this D, and we're going to call that point X and Y. So what is this point here? 0, 0, right? And so what we're actually doing here is, if you think about it, back in your old algebra days, we could think about this distance D as the hypotenuse of the right triangle. And this distance X here is from 0 to this point here, which is X, whatever point on the graph that we decide it to be. And so that would be X minus 0 in this case. And what is the height? Well, the height again starts at 0 and goes all the way up to that point Y. So the height would be Y minus 0. And so when we set up this with the Pythagorean theorem, remember we have x minus 0, whoops, not 10. Get rid of the 10 and put in a 0. X minus 0 squared plus y minus 0 squared equals d squared. And that's the old Pythagorean theorem, where the x here is like the a, the y is the b, and the hypotenuse is the c. Remember Pythagorean square, a squared plus b squared equals c squared. And so we're using that same concept to derive the distance from the origin to any point on this graph. And the beauty of the origin is minus 0, it kind of cancels out. So if it's not at the origin, the equation gets a lot more complicated. So in this class, we're just going to measure distance from the origin. And when you get to trig, you'll come up with some other techniques to do more complicated evaluations of distances. So if we simplify this a little, we have x squared plus y squared, just to get rid of the 0, equals, whoops, I forgot my d squared there. I did say it, I think, but it would be d squared. So we're looking for distance d, right? So distance d, if we take the square root of both sides, it would end up being x squared plus y squared. So what we are doing here in this derivation is we want to have an equation for distance that has a single variable associated with it. So you want to get rid of the y and you just want to leave the x in there. So how do we do that? Well, from our original equation, we know that this equals y, right? X squared minus 1 equals y. So if we come down here, we could do a substitution. And we have x squared here. And then we'd have plus x squared minus 1 squared. So wherever you see x, or y, excuse me, you plug in x squared minus 1. So you do a little bit more of a derivation. And it would be x squared, and then you expand this out, and it would be x to the 4th minus 2x squared plus 1. And you can see that when we combine, we have 1x to the 4th, so, and plus 1's by itself, but you could see that these two combine, minus 2x plus, minus 2x squared plus x squared would give us the equation x to the 4th minus x squared plus 1. So now given this equation, you could calculate the distance from the origin to any point on this graph. So let me do a couple examples for you. So I need a little space here. So I'm going to erase this part so I could do some calculations. So let's do the simplest one first, and that would be what would be the value or the distance, excuse me, when x equals 0. So when x equals 0, what does y equal? Well, that would be 0 squared minus 1, and so it would be minus 1. So where would you be? You'd be right here, right? Right down here. And the distance from the origin to that point should be the number 1, right? Because we're just moving one step down. So let's plug in the values. So if you think about it, we're going to take d and plug in 0 in for x. And so when we do that, we get 0 to the 4th minus 0 squared plus 1. Square root of 1 is 1, and you can see that the distance is 1. Let's do another one. Say like x equals minus 2. So minus 2 would be here, and when you plug that value in, you would get for y, you would get minus 2 squared minus 1 equals 4 minus 1, so it would be 3. So in this color here, let me make it orange. We're measuring this distance here, so that D of orange. So how do we do that? Well, instead of measuring it, we calculate it using our equation. So we have minus 2 to the 4th minus 2 squared plus 1. So do you see, just whoops, sorry about that. So just to reiterate, when you plug the minus in, you have to take it to the 4th. So when you do that, you have 4 minuses. So that turns positive, right? So that would be 16. And this would be minus 4 plus 1. And so when you put that all together, you would get square root of 13. And if you were asked to do that in decimal, you'd have to get your calculator out. And it looks like it's approximately 3.6. So this is the example of finding distance equation using the idea of Pythagorean's theorem. And again, we are only going to measure distance from the origin to any point on an equation that is given to you. So this gives you an example. You'll see in the homework, you'll have another one of these or two of these to try as well. So I'm going to stop this lecture, and then in the next part of it, we're going to talk about the box analysis.